You've looked at it every single day of your life. But if someone asked you right now, why is the sky blue? Could you actually explain it? Most people say something like, it just is, or something to do with the sun. Both are wrong. The real answer is stranger and more beautiful than that. And as a bonus, the exact same science that makes the sky blue is also the reason sunsets turn red and orange. One mechanism, two completely different results. Start here. Sunlight looks white, but it isn't. It's actually every color of the visible spectrum combined. Red, orange, yellow, green, blue, violet, all mixed together. You can see this yourself with a prism. White light enters and a rainbow comes out. The colors were always there. The prism just separates them by their wavelengths. Each color travels as a wave. Red light has long, slow waves. Blue and violet light have short, fast waves. And that difference in wavelength changes everything. When sunlight enters Earth's atmosphere, it collides with tiny gas molecules, mostly nitrogen and oxygen. These collisions scatter the light. But they don't scatter all colors equally. Short wavelength light, blue and violet, gets scattered dramatically more than long wavelength light. Blue light is scattered roughly 10 times more than red light. 10 times. This process is called Rayleigh scattering, named after British physicist Lord Rayleigh, who calculated exactly why it happens in the 19th century. So when sunlight hits our atmosphere, the blue wavelengths bounce off molecules in every direction, up, sideways, downward, flooding the entire sky with scattered blue light. The red and orange wavelengths barely scatter at all. They travel straight through the atmosphere and continue on their path. You don't see them filling the sky. Wherever you look up, north, south, east, west, scattered blue light is reaching your eyes from that direction. The sky is blue in every direction for exactly that reason. But here's the question that stumps most people. Violet light has an even shorter wavelength than blue. It scatters even more. So why isn't the sky violet? Two reasons. First, the sun emits less violet light than blue to begin with. Second, your eyes are far more sensitive to blue than to violet. Your brain receives a mix of blue, some violet, and a little green, and interprets the whole combination as sky blue. Your eyes are part of the answer. Now the sunset. During the day, the sun is high overhead. Sunlight travels through a relatively thin layer of atmosphere to reach your eyes. Blue dominates. But at sunset, the sun sits at the horizon. Sunlight now travels through a much thicker slice of atmosphere, sometimes 50 times more, before reaching your eyes. Over that longer journey, almost all the blue light gets scattered away before it reaches you. It scatters out to the sides, lighting up the sky elsewhere. What's left traveling straight toward your eyes are the long wavelengths that barely scatter, the reds, the oranges, the yellows. That is your sunset. The same atmosphere, the same sunlight, the same physics. The only variable is the angle. Noon gives you blue, sunset gives you red. Rayleigh scattering explains both. And it goes further. After volcanic eruptions, enormous amounts of dust enter the upper atmosphere. The extra particles scatter light differently, producing the most dramatic red sunsets on Earth. The 1883 eruption of Krakatoa produced sunsets so vivid and blood red that people across Europe thought cities were on fire. Artists painted them. Scientists were baffled for months. Now look at this from space. Astronauts looking down at Earth see a thin blue halo around the planet. That ring of blue light is our atmosphere scattering sunlight. From space, there is no sky. No atmosphere means no scattering. The sun blazes white, the stars shine steady, and the background is pure black. Scattering creates color. The sky isn't blue because of the ocean. It isn't blue because of the water and clouds. It's blue because of invisible gas molecules and the physics of waves. A question you've asked since you were a child, answered by a 19th century physicist, confirmed by NASA, and visible from space. Hiding in plain sight above you every day. That's what this channel is. One question, one real answer, every single day. Subscribe to AI Explained and never look at the ordinary world the same way again. Tomorrow we're asking, why are we so tired all the time? The answer isn't sleep deprivation. It's far more interesting than that. And it affects almost everyone. Subscribe and hit the bell. New video tomorrow. AI Explained. See you tomorrow. One question, one answer, every day.